Hi everyone. So in this video, we're going to answer a stats question from an Edexcel past paper, and in fact, it's a first year AS past paper. And it's quite an interesting question because it's a question on histograms, but it involves a bit of integration as well. So I think this would be a good question to look at, especially for you guys in year 12 going to year 13 in September next month. It'd be a good practice to get a look at this question here. So we're going to do that today.
But before we get into today's video, please do make sure you do click like and click subscribe. Click that like button, click subscribe. It really helps me out and it's free. It doesn't cost you anything and it takes you less than a second. So please do click those buttons and we'll get into today's video now.
So it's this question here, this question 3 from this 2022 first year Edexcel stats paper. So we've got a histogram here, a histogram about heights of seedlings. So we've got heights of 256 seedlings 2 weeks after they were planted. So we're going to plant these seedlings. We've got 256 of them, and we're going to measure their heights after 2 weeks. And we've got this histogram, which is representing the heights. So we've got heights on the bottom, our frequency density on the y-axis. So the first part of the question wants us to use linear interpolation to estimate the median height of the seedling. So we've got these heights from 0 centimeters up to 8 centimeters. So we've got to find the median heights. Remember, the median is the middle height. So that if we line up all the heights of our 256 seedlings, where will the middle be? Now, obviously, we can't get an accurate value for that because we don't know the accurate heights of the 256 seedlings. All we know is this histogram here. So we just know that we've got some seedlings between 0 and 1 centimeters, some between 1 and 2, some between 2 and 3.5, some between 3.5 and 4.5, 4.5 and 6.5, and 6.5 and 8. That's all we know. So we're going to have to estimate, and we're using linear interpolation. So if you haven't seen linear interpolation before, it's just a way of estimating things based off histograms or tables, tables of data, in which basically we just assume that the heights of each seedling in each of these groups is equally distributed. So for example, if we look at this this category or this class 4.5 to 6.5, when we're using linear interpolation, what we're assuming is that all of the seedlings who have heights between 4.5 and 6.5 are evenly distributed from 4.5 to 6.5. That's kind of what we mean by linear interpolation. But you don't really need to know that, but it's just good to know, I guess. Okay, so now let's try to do part A then. So remember, we've got 256 seedlings. We want the middle one. So obviously we want to do 256 divided by 2. So 256 divided by 2, that should give us 128. So the 128th biggest seedling is our median. So is our median height. Is our median height. So, okay, so we want to try and find where our 128th biggest seedling is within all these histogram bars. So where is it going to lie? So I guess the way to do this is obviously we need to work out the frequencies within each of these categories, each of these classes. So remember how we calculate frequency using a histogram. So remember that frequency is equal to the class width times height. Well, frequency density, which is the height of these bars here. So frequency density. I'll just call it FD for short. FD stands for frequency density. Okay, so we're gonna just do base times height for all of these 6 bars. So that's what we're gonna do. So we'll start with the first one. So with the first one, we've got a base of 1. So we've got a base of 1, and we've got a height of 15. So we've got 1 times 15. That's going to be 15 there. Same thing with the next 1 to 2. We've got a base of 1, height of 35. So we're going to do 1 times 35. That's 35. Next one, we're going from 2 to 3.5. So we've got a base of 1.5. So class width of 1.5 times by 50. 1.5 times 50, 75. We've then got 3.5 times by 4.5. Sorry, a class width going from 3.5 to 4.5. Your class width is 1. Your height in this case is 55, isn't it? Yeah, 55 up there. And then the next one is going from 4.5 to 6.5. So the class width is 2. 2 times by, that's 26, isn't it? Yeah, frequency density of 26. Double 26 is 52. And then the last one, we're going from 6.5 to 8. That's a width of 1.5 and a height of 16. 1.5 times 16 is 24. Okay, so we've got all our data there. I'm just going to add up our frequencies just to check that they do add up to 256, because that's our total frequency of seedlings. 15 plus 35 plus 25 plus 55 plus 52 plus 24. Yep, 256. Perfect. So it all adds up. So it all looks correct. So how can we use this to work out where our 128th biggest height is going to lie within this range? I mean, it's certainly not going to be in this first group here, is it? It's certainly not going to be between 0 and 1, because the smallest 15 seedlings occur between 0 centimeters and 1 centimeter. So it's obviously not going to be there. We want to find the 128th biggest one, not the 15th biggest one. And it's not going to appear in the next one as well, because 15 plus 35 gives us 50. The 50 smallest ones are in these two groups here, but we want to try and get up to 128. So I think the best way to show our workings with this one is to actually do like a cumulative frequency table. So I'm just going to do a little table down here. So I'll put a title here of class interval. I'll put a title here of frequency in this column. And I put another one here of cumulative frequency. So cumulative frequency. Okay, so the first class interval we had was from 0 to 1. And the frequency that we had was 15. So we'll just put 15 there. So our cumulative frequency is also 15. Okay, so we've got 15 as our cumulative frequency. So then the next one was 1 to 2. So our next interval is going from 1 to 2. So we'll just, sorry, my cursor's just decided to freeze. What a pain. Let me see if I can scroll up. Let me scroll up. Oh yes, sorry. Just bear with me whilst we get up to the top. Yeah, so 1 to 2 is our next group, and we've got 35 people in that category there. So let's just scroll down and write that in. So 1 to 2, 35, and our cumulative frequency is now 15 plus 35, which is 50. Okay, so got 50 in that. Then the next one is going to be 2 to 2.5, isn't it? So it's 2 to 2.5, sorry, 3.5, sorry, 3.5. So we're going to go up 2 to 3.5. So we've got 75 people in that. 75 is our frequency. So our cumulative frequency is 50 plus 75, which is 125. And then the next group was 3.5 to 4.5. The frequency there was 55. 55 plus 125, that's going to be 180. So that's our cumulative frequency. Right, I'm going to stop there. So I'm not going to do the last two class intervals because we don't need to. Because remember, we're just trying to find the median, right? So we don't have to do the other two rows. We just want to find the median. And we know the 128th biggest one is our median. Now we've got up to 128 because we've got up to 180, right? So the smallest 180 seedlings have a height between 0 centimeters, so this 0 centimeters there, and this 45 centimeters there. So what can we tell? Again, so we know that the smallest 125 go from 0 up to 3.5 because look, we've got 125 there, right? So the smallest 125 seedlings have a height between 0 and 3.5 centimeters. So we want the 128. So let's just make this really clear here. We want the 128th seedling. So we want that 128th seedling. So we know that 128th seedling is the third biggest seedling in the class interval 3.5 to 4.5. Why do we know that? Because the first 125 seedlings go from 0 centimeters up to 3.5 centimeters. So 125, 126, 127, 128, that's 3 bigger than the 125 up to 3.5 centimeters. So we know that it's going to be in this category here, this class here, right? So let's just make a note of this here. So just put a bullet point here. So you want the 128th seedling. This seedling is the third biggest in the interval 3.5 centimeters to 4.5 centimeters. So it's the third biggest seedling in that interval here. Now, that means, so how many seedlings do we have in this interval? So total seedlings in this interval, well, we know that that's the frequency, this 55 there. So it's 55. So that's our total frequency within this interval. So the third biggest seedling is the median, but we've got 55 seedlings in this category. So the proportion, or well, the linear proportion, this is why it's called linear interpolation, this kind of linear proportion within the 3.5 to 4.5 interval in which, so the proportion within the 3.5 to 4.5 interval in which the median lies, in which the median lies, is equal to 3, because it's the third biggest in the group, out of a total of 55 in the group. Okay, so let me just make my handwriting look neater. So which is the median, sorry, that should be an A there, really bad handwriting, sorry. So the proportion within the 3.5 to 4.5 interval in which the median lies is 3 out of 55. So it's 3 out of 55 along the interval here. Now, how wide is our interval? So what's the width of our interval? So width of interval is 4.5 centimeters, take away 3.5 centimeters, which we know is 1 centimeter. So that's the width of the interval. Okay, so so the proportion of the width of the interval in which the median lies is going to be 1 times by 3 over 55. So proportion, or let me call it position within the interval. So position within interval in which median lies is going to be the width in centimeters, so the width of our category, so 1 centimeter, and then times by our proportion, so 3 over 55. 1 times 3 over 55 is literally just 3 over 55. So we have that. And then to finally work out or estimate the median, so that's the position within the interval 3 over 55 in which the median lies. But obviously the interval starts obviously at 3.5 centimeters. So obviously the median is not 3 over 55 centimeters because that's about 0. And we know for a fact that the median can't be about 0. It's got to be bigger than that. It's got to be between 3.5 and 4.5. So to get our final median estimate, so median estimate, let me just make that look like a proper M. Median estimate is going to be the 3.5, the lower bound of our class, and then plus our position within the interval. So the position within the interval is going to be 3 over 55. So we can go to the calculator. We can put this in the calculator. So 3.5 plus 3 over 55 is going to be about, 3.55 well, actually, I'm just going to round it to I'll round it to 3 decimal places. So we've got 3.55, and then we got a 4545 recurring. So I'll just round the 4 up to 5 next to it. So that's to 3 decimal places. So that's going to be our median, and this is obviously in centimeters. Just make sure it's in centimeters there because we're measuring heights. Heights are in centimeters. So that's part A of the question. That's how you do linear interpolation, but that's obviously not the integration part of the question. The next 2 parts are going to be integration. So this is the interesting part that most of you are here to watch probably. So now Chris decides to model the frequency density for these 256 seedlings by a curve with the equation y equals kx times by 8 minus x, where x is between 0 and 8. So obviously, you know, if you're modeling frequency density, so if you're modeling this histogram here, which is what he's trying to do, so he's got this curve and he's basically trying to model the histogram using this curve. So you've got this kind of, well, it's a quadratic curve. How do we know that? Because when we expand the brackets, that times that times that, we would get 8kx take away kx times x, which is kx squared. right? So this is a quadratic. K is just a number, just any random number. This is a quadratic. So basically it's going to look some kind of quadratic like that. And he's using this quadratic as a model for this histogram. That's basically what he's doing. So the question is to find the value of K. Okay, so how are we going to do that? So we've got to think about what histograms are. So remember, this curve that he has come up with, this curve that Chris has come up with, is a model for the histogram. So it's supposed to imitate or copy the histogram. It's supposed to be like a impersonation of the histogram. Now, what does a histogram represent? So remember, the area of the bars in our histogram is the frequency. Okay, so the area. So basically, you can think about it like an integral, right? So basically, if you integrate all these bars up and add them up, right, then that's going to be your total frequency. So if we've come up with a graph which is supposed to impersonate a histogram, then the area under the graph needs to be the total frequency, just like a histogram. The area under a histogram is the total frequency. We've got this model trying to impersonate the frequency, sorry, the histogram. So the area has got to be the same as the frequency. And how do we find the area under curves? We integrate. So with this part B, let's go down here, part B. So we've got this equation and we've expanded it. It's probably going to be easier to use the expanded form to do the integration. So we've got this curve, which is 8kx take away kx squared. And we want to integrate that curve because we want to find k. We don't know what k is. We're going to integrate that curve. And what are our limits of integration? Well, we've got seedlings between 0 centimeters and 8 centimeters. So we integrate from 0 to 8. So 0 on the bottom, 8 at the top. We integrate with respect to x. And because, remember, the area of your histogram, the area under your histogram is your total frequency, the area under this curve modeling the histogram therefore needs to be the total frequency, which we know is 256. That's our total frequency. So now let's go ahead and do the integration. So integrating 8kx with respect to x, add 1 to the power of x, divide by the new power. We get 8kx squared over 2. And then similar to the next part, so add 1 to the power of x, we get 3. So kx to the power of 3. Divide by the new power, we get 3 there. We're integrating between 0 and 8. And again, this is supposed to be equal to 256. We just put the equal sign there. Now, how do we integrate with limits? We substitute in the top limit first. So let's do that. So we've got 8k times by 8 squared divided by 2. Take away k times 8 cubed divided by 2. And then we take away what we get when we substitute in the lower limit. If we plug 0 into x squared, that gives us 0. So we've got 0 times 8k over 2, which again is 0. That's going to be 0 there. And again, when we plug in 0 into the second term, k times 0 cubed is 0. 0 divided by 3 is 0. So we actually got 0 there. And again, this is all has to add up to 256. Okay, so then now we're just going to simplify what we've got. So we've got 8 squared, which is 64 times by 8. Can't do that in my head. 8 cubed. So 512. So we've got 512 there, divided by 2, and then times by the k, obviously, there as well. And then take away 8 cubed, which is again 512. Have I done something wrong here? So, oh yes, sorry, yes, I've noticed what I've done wrong. Yes, I was wondering because I was this should be a 3 there. This should be a 3. Yeah, sorry, my bad. That's a 3 there. So yeah, 8 cubed 512 times by k divided by 3. Obviously take away 0, but we don't need to worry about that. Is equal to 256. So we got 512 over 2, which is 256. You got 256k. Take away 512 over 3k, and this is just going to be equal to 256. Take away 512 over 3, lots of k. Do that on the calculator. 256 take away 512 divided by 3. So I get 256 over 3. So 256 over 3 times by k. And this is our integral. So we just worked out the integral. That is the area under the curve. But remember, the area under the curve needs to be exactly equal to the total frequency of 256. So now then we can work out the k value because we've got this equation here, 256 over 3 times by k is equal to 256. So what will our k value be? It's going to be 3. Okay, it's got to be 3. So therefore k is equal to 3. So if you times both sides by 3, divide by 256, you get 3. Or also you can just realize, well, 256 over 3 times something has to equal 256. If that's a 3, then the 3 there just cancels out. So k must be 3. So that's going to be our answer to that question. So k is 3. And then the last part of the question, so using this model, write down the median height of the seedlings. Okay, so now we're not using the histogram, we're using the model equation. What would be the estimate for the, using the model, what would be the median height for our seedlings? So to do this, let's think about the graph that we have, because I think sketching the graph to see what the graph looks like would help us out. So we've got our curve. If I just fit this part C down here. So we've got our curve y equals, let's scroll back up again. So it's kx times by 8 minus x. Now k we just worked out to be 3. So our curve is actually y equals 3x times by 8 minus x. So when we get a question about medians of curves, basically what we're doing here is finding the median of the graph. So what we want to do is basically have a little sketch of that and see what it looks like. So we've got y equals 3x times by 8 minus x. As we said before, it's a quadratic. I'm actually just gonna, don't have enough room really, but let me just try and fit the quadratic in over here. So it's gonna be a quadratic. Now, what will the roots of this quadratic be if we set this equal to 0? So 3x times by 8 minus x equal to 0. We're gonna have two solutions. So either 8 minus x equals 0, in which case x would be 8. Or alternatively, 3x could be equal to 0. And if 3x is equal to 0, it means x is equal to 0. So we get those two solutions there. So you plot those there, 0 and 8. It's a quadratic, but it's a negative quadratic because remember, we've got negative x squared. So we've got, 24x there, that's 24x. And then we've got a negative 3x squared there. When we've got a negative coefficient of x squared, it means it's a negative quadratic. So instead of a positive U shape, it's going to be an upside down U shape like that. Well, it should go for 8 there. I'll just move my cross along to make that look like 8. So that's our quadratic. What would the median be? So we're going from 0 centimeters. So that's, remember, our x-axis in centimeters, going from 0 centimeters to 8 centimeters. If you had to have an educated guess, 0 to 8 centimeters, what do you think the median would be? So the middle centimeters, the middle height. Well, it's going to be 4. Because 4 is in the middle, so 4 is in the middle there. And remember, quadratic curves are symmetrical. So let's just be really clear about why this is true. So this curve is symmetrical. So it's symmetrical about x equals 4. Okay, we've got a line of symmetry on this line here, x equals 4. So therefore, the median is equal to 4. Okay, so the middle, remember, the median is the middle height. If you've got a perfectly symmetrical distribution of heights, because that's kind of what this is suggesting here, with 4 in the middle, it would suggest that your median is 4. Now, if you had any random curve and you wanted to find the median for a curve, so I'll go to the whiteboard to go through this because I think this is quite an interesting point to make. So let's say instead of having our symmetrical quadratic curve, we had a harder question. Let's say we had a curve like this here, and that was 0 centimeters there, and that was 8 centimeters there. And then we had to find the median. So I'll just put a title here, find median. So to do a question like this is a little bit different. What we're going to have to do is realize that, again, a median is the middle of your data. So it means that 50% of values are less than your median and 50% of data values are greater than your median. So just make some bullet points here. So 50% of data values. Well, I mean, it may, in real life, it may not necessarily be exactly 50%, but that's the idea. That's the idea we want, especially with continuous data like this, right? That's going to be true always. So 50% of data is less than the median, and 50% is greater. So that means that, I mean, let's just put our median here, for example. Let's just say the median is there. So the median is the point on the x-axis which satisfy the condition that this area here is 50% of the total frequency. So that area there needs to be 50% of the total frequency. And so likewise, the area bigger, so this like blue area there also needs to be 50% of the total frequency as well, just because, you know, obviously 50% plus 50% is 100%. So if we want to find a median for any random curve, not a quadratic symmetrical one where we just go in the middle. Again, if you had a quadratic curve like the one in our question, just go in the middle, line of symmetry, that is your median. For more difficult curves like this, you want to think about this like this. So your area to the left of your median is 50%. So I'm going to call the total frequency x. So total frequency is equal to, sorry, I call it f, capital F. So basically what we're saying is that if you integrate your curve from 0 centimeters up to your median, so you're going to find the area under the curve from 0 centimeters up to your median, and you've got some function. I'm just going to call this f of x. Let me just call this curve here f of x. So we've got a curve f of x. So you're going to integrate your curve from 0 centimeters to the median centimeters with respect to x. And that must be equal to half of your frequency. So this is the formula that you can use to find the median for a curve. Sorry, let me just put a box around here. So this is your formula. So formula to find median for a curve. Now, well, let me be more precise. For a curve depicting or representing or modeling a histogram. So for a curve modeling a histogram, that's your formula. So if you had, let's just say that this was x squared. So let's just say that f of x equals x squared. You'd plug x squared into it. You'd integrate from 0 to m x squared. So m is a number you don't know, but you plug, when you do your integration, your definite integration, you plug m into your integrand when you do, sorry, your integral when you've done your result, when you've integrated it, and that's equal to half your total frequency. So the frequency you'll know from the question because you work that out from your histogram. So let's just say, for example, the frequency is still 256. Half of 256 is 128. So you're going to integrate x squared between 0 and m. And I'm just going to do this down here very quickly because I do want to just show you guys how it works in case you're a bit confused. So what you would do, let me get the black pen. There we go. So it's going to be integrating from 0 to m. If this curve is x squared, it's going to be integrating from 0 to m x squared with respect to x. And that's going to be half of our frequency. Let's just pretend that f equals, actually, I'm going to change this to a different number. Let's just say 100. Let's say you've got 100 seedlings instead. So that's going to be, so your formula, remember, is half of your frequency, because remember, median is in the middle, so half of your frequency needs to be to the left of your median. So half of 50 of 100 is 50. So you're going to do your integration. Integrating x squared gives you x cubed over 3, and you're integrating between 0 and m, and that's equal to 50. You're going to plug 50 in. Just try and move this up a little bit. Actually, do you know what? I'm gonna continue up here. Let me continue up here. So we're going to plug in m, so we get m cubed over 3, and then take away what we get when we plug in 0, so 0 cubed over 3. Again, this is equal to 50. 0 cubed, obviously this is just 0 there, that's just 0. So we get m cubed over 3 equals 50, times both sides by 3. M cubed is 150. So that means that m, I'll just fit it in here, your median is going to be the cube root, so cube root of 150. Hopefully you can see that, but that's just squished in at the end. So that's how you would do a median calculation for a random curve if you ever got a question like that. But any questions, do drop them in the comment section. Hopefully this did help you out. But if we just go back to the question, the final answer is 4 for this one in the exam, this part C to this this histogram question. So again, yeah, any questions, do leave do drop a comment below, and please do ask me if you do need any help with anything that we've done in today's video.
If you are interested in having an online maths tutor for either A-level maths or GCSE maths, please do email me because I am available to help out. So my email is drdifferentiation@gmail.com. So just drop me an email, just drop me some details about you, whether you're doing A-level maths, GCSE maths, and if there's any specific areas of maths that you need help with. So drop me an email or get your parents to drop me an email, and then we can discuss everything about price, etc., etc. So drop me an email and we can get sessions booked in.